All right, friends, this is where we put everything together in terms of what we have learned in our geometry unit. So you are going to be given a bag of 6 polygons, okay? And in that bag of polygons, here are your 6 polygons. You're going to put them in whatever order you want to put them in, okay? I'm going to put one here. Again, doesn't matter where I decide to put it. Doesn't matter what flip side they're on. I'm going to put one polygon in each box, okay? Now, once I have put one polygon in each box, what I'm going to do is I'm going to trace that polygon, okay? So I'm going to go ahead and trace it. And again, it does not matter what order the polygons are in, okay? But you want to make sure that you trace it and you get it in there good, okay? Because you're going to be measuring those angles, all right? So make sure that you have it in there good. So I'm going to start with just that very first one. Now, reading the directions, it tells me you'll need to trace each polygon first and then show the angle measurements. Label each polygon with its name and the angles as acute, obtuse, and or right. Also indicate if there are parallel lines, perpendicular lines, or lines of symmetry. Okay, so I'm going to remove these for a second, and I'm just going to demonstrate with this very first one. I'm going to take that good old turtle turner back out, the one that I told you to hold on to, and I'm going to make sure my arrow is lined up on the line here, okay, and I am able to tell this is a 120-degree angle, so I'm going to label that as 120 degrees. Then I'm going to go over here, okay, and I see that angle. Again, you have your arrow right here. That angle turns out to be 60 degrees, okay? Then I'm going to go up here, moving it. I find out the angle is 120 degrees. And then over here, the angle is 60 degrees, okay? Now, I'm going to go back up, and I'm going to think to myself, are these acute, obtuse, or right? Well, we know that they're going to be acute angles if they are less than 90 degrees. So I'm going to label this acute. I'm going to label this acute, okay? And I know that if it's greater than 90 degrees, then it's going to be considered a obtuse angle. So I'm going to say this is obtuse, and I'm going to say this is obtuse, okay? Now it's asking me to determine if there are parallel or perpendicular lines. Okay, well, we know that parallel lines are lines that never touch. So if we take this here, this line, okay, parallel to this line. So I'm labeling it as parallel. And we know that this line here, okay, is parallel to this line here. Perpendicular would mean it makes a 90-degree angle, so there is no perpendicular lines. However, for lines of symmetry, we have a line this way. And we have a line going that way, okay? So we have 2 lines of symmetry, and we have 2 sets of parallel lines. And then we want to give our polygon a name. We know that it is a quadrilateral, okay? And what type of quadrilateral is it? It is a rhombus. Okay? We know that it's a rhombus because the sides are all the same length. If you actually measured them, you would see that these 4 sides are in fact all the same length. It's not a square because the angles are not 90 degrees, but they do have those equivalent side measurements. Okay? So you're going to do this with every single polygon. That is part 1. So I've shown you how to do part 1. Now, for part 2, on the back, it tells you, and we call it a project because it might not be something you're able to do in one day. It's asking us to create a pentagon, combining 2 of the polygons. So you have to figure out how you can create a pentagon using 2 of the polygons, and then you're going to repeat the same process that you did with just the 1. All right, I know that a house makes a pentagon. So if I take my square and my triangle and I combine that, I will have 1, 2, 3, 4, 5 sides. And I know that a 5-sided polygon is a pentagon. Could I potentially do that with something else? Sure. Okay, let's see if this makes a 5-sided polygon. We have 1, we have 2, we have 3, we have 4. No, that's a quadrilateral, so that won't work. Okay, what if I do it this way? Would that make a pentagon? 1, 2, 3, 4, 5, 6. No, that makes a hexagon. So this could be potentially down there. Okay, you're going to do the same thing. You're going to create a pentagon, a hexagon. You're going to go on and create a septagon, and you're going to create an octagon. And you're combining 2 of the polygons. If you want to combine more than that, as long as the sides come out the same, that's fine. And then on the very, very last page, this is where you actually can take a combination of polygons and create a large polygon. You can use, 3 or more is going to be the key to do this, because you're going to be creating a cool picture with it. So you could create a picture, anything you want, okay? Could look something like that, okay? You could just use those if you want. You want to use at least 3, trace it, determine the angle measurements, tell me what the name of the polygon is, if it's acute, obtuse, or right, parallel lines, perpendicular lines, or any lines of symmetry. And that, my friends, is the project in a nutshell, okay? Now, make sure you're using your mathematical tools correctly, okay? These do have some sharp edges, so please be cognizant of safety, okay? And of course, you're using your turtle turner for measurements. If you have any questions, I will be more than happy to come around and help you, but I know that you can do a great job with this as we put everything together and finalize our geometry unit. All right, friends, when you're done, color it in, make it look nice, okay? And turn it into me, and I will grade it. All right, have fun.